Hi class, in this video I'm going to go over the solution to the lab portion of the sample exam. This problem is of similar level you should expect to see on the exam. So what you'll be given is an assembly. You won't have to model any of the parts, but you'll get a bunch of parts and you'll have to put them together. So you want to carefully read the problem statement. And it's saying here that you must edit the joint so that no components mechanically interfere. So that's like nothing overlapping with each other. So no solid material overlapping with each other. For this test, you will not be allowed to use contact sets, so you'll have to do it using joint limits. Okay, and also you need to capture the motion as indicated in the diagram below. So I'll probably give you multiple views. Here's an axiometric view, and it's showing you that this lead screw, as this thing screws out, it shouldn't exit this nut because it would fall apart. Now, yes, it would be free to, but we want to limit that motion. And we also, if you're screwing this screw forward, uh, this threaded part right here, it shouldn't be able to go through this non-threaded part of the lead screw rod. So that's something that we need to limit with a joint. This needs to be free to rotate, this little arm right here. And then what you're seeing here is a section view, and you're seeing that the lead screw is free to rotate and translate through the nut, and it translates one, or this is actually, I have to check the units on this. I guess this is 100 thousandths of an inch per degrees revolution, 360 degrees revolution. It's also saying that up top and down low, that these swing arms right here, they will rotate with each other, but for every 360 degrees this arm rotates, this one must rotate negative 360 degrees. And we want to make sure that these little geared teeth, that they're not going to interfere with each other. And then finally, make sure you know which component should be grounded. In this case, that is the base. Let's go ahead and take a look at the model and see if we can put this thing together. So step one for us is going to make sure that this base component here is grounded. And you can see this little pin that it is grounded. But just in case it wasn't, if you were to right click on the component, there's the ground. And what that does is that I can't move it around. If I click it, I can't move it around. All the other pieces right now, if you click them, you can move them around. One thing that may make it easier is if you go into inspect or just press Shift N, you can make these color coded, and that makes it a little bit easy. So in kind of brainstorming this, one thing might be that these pins, they could be free to rotate in here, but you don't really need to add any extra degrees of freedom if they're not needed. So it doesn't really, like if this pin were to spin in this hole, it's not really helping or hurting. So I'm just going to make it rigid to make this more simple. So if you go to Assembly and click on the Joint tool, or just press J. So from now on, I'll be pressing J, and I'll continue. What you want to be able to do is, a lot of times there's a ton of joint options. I want to be on this axle of this pin, and if you hold down the control button, then that won't let me select. See here, I can't select any of the joints, where if I don't hold it down, it's kind of difficult. So hold control, and then let's go ahead and put that on this face. I'm holding control again, and then I'm get a coincident. Now I have a cylindrical joint type. I'm going to go ahead and change that to rigid for now. Okay. And then I'm going to use the joint tool again, J. And so I got something that looks like that. What do? All you need to do, if the joint, now you see this face is meeting nice and flush like I had indicated, it's just in the wrong direction. All you need to do is flip it. Okay. And let's go ahead and add the pins up top. So I'm going to go J, holding that control button. Make sure you're getting in the center of this hole. So now let's add joints so that the lower arms are in place. So I'll press J, click J, and then Control. Select that center point of that eye. That's going to go on this shaft, but I don't want to join it to the shaft because I don't have a real good spot to pick it up. So I might just put it next to this face, flush on that face. Maybe you're thinking, hey, that's a good spot to put it in. But now I click OK, and I realize I can't move this joint. Why not? Well, because it's rigid, and you may even want to turn on your joints. So if you click the light bulb next to the joints, you can turn it on. And so that last joint, I need to edit it. So right click and edit it, change its type to be, let's just do a revolute joint. For the most part, it's nice to limit the degrees of freedom, and we really just want to capture that this joint can spin. And so I'm going to go J, get this joint, do the same thing. Make sure you change that to revolute. Okay. Now let's make the joints on the top, so the upper arms. So I'm going to go J, there we go. Starting to look good. I see this guy right here. I'm going to add it to that face right here. Okay, it's starting to come together. Now, what we'll see is there's a threaded nut, and then there's one that's smooth that just lets things spin in it. So let's take a look back at the exam. Okay, so it looks like that the threaded nut is on the left side. Okay, so going back, let's add this joint on this face here. Pressing Control will let us pick up that spot. Let's add it right here. Okay. I'm going to go ahead and add this guy's joint right here. So click J, Control on that face. I'm going to add it right here. Okay. And I'm going to move stuff around because it's going to be easier to see. So you can capture position and then press J. And then I'm going to try to add it to this face right in the middle. Okay. And I get a warning. Uh-oh. It's not going to let me do it. What is going on? And this might happen to you in the middle of your exam, and you're sitting there and, oh no, all the joints just went red. What happened? Let me roll the history back so not everything is red. That's kind of scary. But what is going on here? Okay, and what's going on here is you're going along thinking, oh, we're doing everything right. I'm actually show you a view from the left. And what you'll see is that when I added all those revolute joints to these faces here, there's a little bit of gap. That's because there should be some clearance here. And so since I was picking up on this left face, or right face here, the left face of the right side, what I did was create a gap over here. And that is, it's kind of okay, but there's a problem. And let me show you what this problem is. As I was going through and adding these joints, what I did was I joined this onto the right side face of this left edge of the top bracket. Why is that a problem? Well, now what you can see is if everything is riding on the high side here, but this thing over here is not allowing it, what I've basically done is that there is no possible way this thing, and if you kind of come down, let's take a look at the top, like where it's just sitting right now. It's actually got a conflict. So it can't, because it's been pushed to the side, it can't join where we wanted it to do. So the quick and dirty way to do this is to change up, because we don't want them all to be cylindrical joints. If we made these all cylindrical joints, we wouldn't have any control over where these pieces are going. But we could add a degree of freedom to just one of these joints, and that will let it accommodate this translation. So if I go back to this joint, which is our problem child, this Rev 49, and you edit that joint, and if you go ahead and make that one a cylindrical joint, okay, let's see what happens when we try to roll back our history. It now lets it join. Okay, so that's good. Is just adding that 1 degree of freedom is going to let us get this joint that we wanted. There's a better way, and I'll go over that at the end of this video, but if you're on the exam and you just want to get it done, adding that 1 degree of freedom so that we didn't have the joint conflict is the quickest way. The better way might be to make sure that all of these joints, because I've got this funky gap here. A better way might be to make sure that all of these joints have center to center alignment. In order to do that, what you're going to have to do is build in joint origins. Okay, and make center point joint origins. Okay, so let's continue along. And what we might want to do is make a cylindrical joint because it's got to slide and translate through this threaded part. So let's go joint, I'll capture position, and I'm going to go right here to right there, and let's make that a cylindrical joint. Okay. And then let's make another joint. Actually, before I do that, let's join this little bushing. Where does it go? Let's take a look. It looks like that bushing is right here. Okay, and we can see it in the other picture. It's right there. So let's go join here. And I could give this some degrees of freedom, but it's honestly not necessary. So I'm just going to go ahead and make this a rigid joint and flip the direction. Okay, and then I'll make one more joint here. And I'm going to just let this, since it's not supposed to translate, like the bushing wouldn't let it translate through here. And then there's these little wings right here that's not going to let it move through this holder. So let's just make this a cylindrical or a rotational joint. So let's go ahead and make it a revolute joint. Flip the direction and OK. And by adding that 1 degree of freedom of the cylindrical joint, it's letting it accommodate it. If you hadn't done that, it would actually have a conflict right now. But now we don't have that conflict. And then I'm going to go ahead and let's join in this guy right here. So joint, continue this, and it's supposed to be, let's take a look. It's supposed to be free to rotate in here. So we want this little crank arm free to rotate. So press Control, and then I can easily click that joint origin in the middle, and let's just let it be a revolute joint. Okay, so I'm not done yet though, because I come back to my problem statement, and now I need to edit the joint limits and make joint relationships so that it captures all these. So I need this joint relation, I need this joint relationship, and this one. I'm going to go ahead and add these rotational joint relationships. Okay. One thing will be is that right now, I can't just put it in place. So if you just go ahead and add the joint relationship in place, you may get collisions. So like you might have it so that these gear teeth are interacting with each other. So that's not good. One thing that we know is that we should know that at the limits, so either 0 or 90, these arms would have to come together. So what you can do is you can take your joint, so drive the joint and put it at a limit. So I'm going to go 90 degrees here and say, okay, I'm going to take this guy, drive this joint and say 90 degrees. Oh, and I better do negative 90. Okay, go ahead and capture the position. And actually, you know what, on top, let's go with this, these joints up here. I'm going to go ahead and drive that joint to be 90. So this cylindrical, say drive joint, make the angle 90. And this one is 92. So now I'm going to capture, oh, Control Z. Let's go ahead and capture that position. So why is this important? Well, if you come in and look, what I've got is there's no contact right now. And it might even be a good idea is to take your, and I always like doing this, is make a section view. So if you make a section view, let's go ahead and show the origin. And I'm actually going to have to move it halfway through this face. Okay. Why section views are nice is that now it's kind of letting me see what's going on in the middle. So when it is at 90 degrees, I don't have any interference, and these are actually, the gear teeth here are now going to interact properly. So let's go ahead and now that it's in the correct position, we can go and set our joint relationships. So I'm going to go ahead underneath Assemble, go to Motion Link, select the joints. Well, it's this guy and this guy. And what we need is for every rotation, one rotates, the other should rotate the opposite direction. So you can type in negative 360 or you can reverse the direction. So that's looking correct. Okay. So now we've got that and you can play with it. So now it's actually a good idea in the section view to take a look at it, and you'll see I don't have any mechanical interference. So that's really good. Okay. I'm going to go ahead and revert position because I want to be in the right spot for the upper joints, and go ahead and click, go ahead and assembly and take a motion link between this joint and this joint. And since one of them was cylindrical, what we need to make sure it's not a slide, it's both rotate. So rotate to rotate. And that's actually looking, actually let me reverse this. Nope, it is correct as is. Okay, so now what you can see is this thing is standing up and going down. Now what we need to do then is limit the joint motion so it can't go through the base plate. That's a mechanical interference that we should be able to limit. But before we even do that, I'm going to turn off my analysis, is let's go ahead and add the lead screw mechanical joint relationship. So a good choice might be the revolute joint over here, because every time this spins, what we want, since this guy, the nut over here is threaded, we want the thread to be moving. What that will do is move our jack stand up and down. That's what this is. It's a jack stand you might find in the back of your car to repair your flat tire. Okay, so let's go ahead and do that. So let's go assembly. Let's make a motion link, and I'll just continue. So it's going to be up here. And the joint I want to pick out, I'm looking at it right now. Actually, I've already selected it. And then it's the cylindrical joint over here. So I'm going to click right there because that's that cylindrical joint. So what we need to change this time is now for every revolution of our revolute joint, we need to not rotate, we need to slide. And we were given that it was 1/1000th of an inch, or sorry, 100 thousandths of an inch. Okay, let's go ahead, and it won't animate correctly, but let's just take a look at that. One thing we can do is take this joint, the revolute joint, and drive it. So if I screw right-handedly, it should bring it together. So that's actually looking correct. Now what's not correct is it's screwing on a non-threaded part, but you'll see here is if I, yeah, so to lower it, I'll screw the righty-tighty, lefty-loosey. So this is looking good. Okay. And now what I'm going to do is, since I've captured that motion, I'm going to actually move this piece right here just freely, and you can just eyeball this. You don't have to actually press the move. And so it's like, okay, right about there, my threads end. And what would happen is the threads on here would bite into this, so it wouldn't allow it, it would get stuck. So right here is sort of the limit, and let's just make sure there's no other mechanical joint interferences. Doesn't look like it. I'm going to turn off my origin. Okay, so what you can go do is if you say drive joint limits, you'll quickly see that that distance right there is 10.366 inches. So that's one of my joint limits I need to set up. But I need to go the other way. So what I want to do, so let's bring this thing down. And I want to make sure that I'm not going to have any other mechanical interferences. And actually right here, I'm getting a little bit of, it might have some collision. Now, what you can do on your exam is you can go to inspect, and then you can say compute. So under inspection, you can do interferences, and then just select everything, and then go compute. And I do have an interference, but this one is actually okay. So where is it? It's right here, and that's because the way that these threads were modeled, there is always going to be an interference right here. But that one's okay. What we didn't want to see is you don't want to see an interference between these components. And so right here, I'm actually going to limit this a little bit. I'm going to move it up. And this is just as good as you can get. So it's not like I'm looking for an exact number here. I'm just seeing that you do a pretty good job of capturing the functionality. So about right there would be the limit. If it comes down anymore, since these are free to move back and forth, that should limit this. So let's go back to that cylindrical joint, drive it, and it's 31 thousandths of an inch, so 0.031 inches. Okay, and so now I have my joint limits. So you can go to that cylindrical joint and say edit joint limits, and let's give it minimum, and we're editing the sliding. So the minimum value for sliding is 0.031, we just said, and then the maximum was 10.3, and you know what, let's, instead of that 366, let's just do 37. Okay. So what you'll see now is that I'm not allowed to move it any further than that. And let's go ahead. One thing you might find is that even with when all these components are grounded and in place, it may be hard. Like I'm trying to move this thing around, and you're like, oh no, is my motion, is it correct? What you can do if you want to check is I need to be able to drive this joint right here, and it should move. So you could drive this joint, and let's see if it's capturing it, and it is. So by turning this righty-tighty, I'm lifting my jack stand, and by turning it counterclockwise, I'm able to bring it down. And what you'll see is that it won't actually let me turn it anymore. So that my joint limit has kicked in right here and it won't let me turn it anymore. And let's drive it the other way. It's going to take a while. It might be quicker to try to just pull it up. No, it's... So the other thing you can do with this cylindrical joint, you can drive this joint. We could move it this way, and what you'll see, this thing was spinning really fast, but now it's not going to let me drive it any further. Okay, so that's looking pretty good. Let's see here. Okay, so we've done it. So now we've fully captured the functionality, and this would be a 100%. So I will go over now the alternate way of how you could put this together without making one of these joints a cylindrical joint. So another way you could make sure that you were able to get these things to join together without having any conflict would be to make artificial joint origins. So if you were to make a joint origin as a center to center between two faces, you could go into a joint or into these components that don't have joint origins and make center origins. So if you press Control, so now I'm making a joint origin there, and I might make a joint origin here. So if you right click, repeat joint origin, and between two faces. And let's select our origin to be right on this center point. Okay. What we could do is when we go to joint, we could do our revolute, do that center point origin, and then snap to the center point in between the base. And then what we've done, if you look from the side, is now we've enforced that it's right smack dab in the center. And what that will do is if you do this with all of the joints when you put it together, then you should enforce that the alignment will be able to come together. Now, it might be easier for time's sake just to actually just add that extra degree of freedom by making one of those joints a cylindrical joint. But hopefully this helps. Now that you have seen this video, I would say try to, if you weren't able to get the solution, try again and see if you can get the solution. And good luck.